Today we're going to be exploring a little bit more about right triangles, specifically looking at area and perimeter, and then we're going to be dealing with some composite shapes, meaning we're going to be combining shapes together to find different things about them. So this is the last new piece of information before we move into spring break. Next class is going to be more of a review/reflection time. So try these problems out, then go on to Classroom, try the other practice problems there. And you can always reach out to me if you have any questions. So let's get started. Like I said, today we're going to be dealing with perimeter and area. These are not new. Can you just share with me what you remember about finding the perimeter of a triangle? And what do you remember? There's a formula for finding the area of a triangle. What is that formula? All right, so now let's see if we remembered correctly. When it comes to finding the perimeter, all you have to do is add all sides. So for the perimeter of this first problem, you're going to add 2 plus 2 plus 1.5, which gives us 5.5. Since there's not any inches or centimeters or yards, we're just going to label it units. 5.5 units is the perimeter. All right, and now you tell me what the perimeter of the second triangle is. Great, when you add them all together, you'll get that it is 30 units. And now let's find the perimeter of this third triangle. What is stopping us from being able to do this right away? Right, we don't know that other side, but it is a right triangle, so we're able to use the Pythagorean theorem or our memory of those special triangles. There's some special Pythagorean triples to find that missing side. So what is the third side that we're missing in this situation? Great, so whether you did Pythagorean theorem or you remembered that this is a special triangle called a 3, 4, 5 triangle, that missing side is 5. And then we're going to add them up to find the perimeter. 3 plus 4 is 7, plus 5 is 12, so it's 12 units is the perimeter in this situation. Alrighty. Now let's move right on ahead to area. So area, let's see if you remembered the formula correctly. The area formula for a triangle, there's two different ones. Area, you can write it as either 1/2 base times height, or you can write it as base times height divided by 2. Now, base and height aren't necessarily a side length on the triangle, because we have to be able to make the height of the triangle, but that's not necessarily the side length. In this situation, the height is going to be 2. It's where that right angle is made. So we would be doing 1/2 times 2 times 16 to find the area of that triangle. When you do that, you get area is 16 units squared. So there's no units once again, but we always represent it as square units because it's talking about the full area. All right, now you find the area of the second triangle. Yes, it's spun, but that doesn't make any difference. We can still use those numbers as the base and height. If you did that correctly, you should have gotten 33 units squared. Okay, now moving on to our last problem. We have two side lengths once again, but one is a leg and one is a hypotenuse of a right triangle, but we need both legs to find the area. We need the base and height, and the 5 just isn't either of those things. So we're going to once again use the Pythagorean theorem. This is the same type of triangle we just did in the last problem though. So if you remember, you'll know that that missing side is a what? What is our missing side for this triangle? Good, it's 4. And if you want to find the area, you'll do 1/2 base times height or base times height divided by 2. I'll show the other way. Base times height divided by 2. So 3 times 4 divided by 2. 12 divided by 2 equals 6. So our area is 6 units squared. And that's how you find the area. So hopefully that's not new, just a quick review. And now we'll use it to explore what I call composite shapes. So this is just a quick freehand sketch of what a composite shape could look like. You see that there's 3 different triangles embedded in that. So looking there, we can see that if I were to ask what's the area of this whole figure, well, if I can figure out the area of each triangle, I can use that information to find the area of the whole figure. And if I wanted to find the perimeter of this whole figure, if I find each of those sides and add them up and ignore those internal lines, then I can find the perimeter as well. And that's the kinds of problems we're going to be looking at today. So here's my first problem. The first question I have for you is, what is the area of that blue triangle? So I want you to look at this and ask yourself, what information do I need and what information do I have or not have? Look at that and think about that for a second. So, and yes, I know it's not drawn to scale. This side is 3 inches and this side is 10. We're just going to go with it even though it's not drawn to scale. Now, if I'm trying to find the area of that blue triangle, I need to find the base and height of it. So let's say I'll make this the base and this the height. Do I have enough information to find those sides? I do, but it's just a process of figuring out what it is. So for this side where I put the base, that's actually the hypotenuse of that first triangle. So I can use the Pythagorean theorem, 3 squared plus 4 squared equals c squared or b squared. I probably shouldn't have used that letter, but you get the idea. And we've done this one already. 9 plus 16 equals c squared. 25 equals c squared. So we take the square root of both sides, and we know 5 is the value of c. So now I can say that this value is 5. And now I'm going to look for this other value of h, and I'm going to do something very similar with 6 and 10. In that situation, though, 6 is a leg and 10 is the hypotenuse because it's the one opposite the right angle. So you have to be careful about which numbers you're using. So I would have 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. Subtract 36 from both sides. All right, I'm going to pause here. You finish the rest of the problem. What is the value of b? Great. The value of b is going to be, we have b squared equals 64, square root both sides, b equals 8. So we now know that the base and height of that triangle are 5 and 8, and we can now use that information to find the area of that blue triangle. 1/2 base of 5 times height of 8. What is the area of the blue triangle? Good. The area is going to be 20, and then let's check for units. I see that it is inches, so 20 inches squared. I could also ask a whole bunch of questions. What's the area of the whole figure? What's the perimeter of the whole figure? But for the sake of time, we'll move on to the next one. We'll ask one of those problems for there. All right. Now for this figure, I only have one measurement and a bunch of missing pieces, and I want to find the area of that orange triangle. But what type of triangle is the white triangle? So you could have either said it was an isosceles right triangle, or you could have said it's a 45, 45, 90 right triangle. Using that, we would know this other side is 7. And if we remember that special triangle relationship of 45, 45, 90 triangles, we know this side is going to be, whoops, I don't know why I said 4. 7 radical 2. Now, the orange triangle is also what type of triangle? Good. It's also an isosceles right triangle. It's also 7 radical 2. I want you to do a couple things, but to start, I want you to now use that information and find the area of the orange triangle. So let's go and see what happens. I know you may have never kind of multiplied this way, so let's see how it went. So it's 1/2 base, which is 7 radical 2, times 7 radical 2. Now when you do this, I'm going to multiply these two together. Whatever is outside the radical can get multiplied together. So 7 and 7 are getting multiplied together. Whatever's inside a radical can get multiplied together. 2 times 2. So 7 and 7 become 49. Radical 4. Oh, don't forget that 1/2 from the beginning of the problem. These are all the numbers we're multiplying by. Now radical 4 simplifies down to what? Radical 4 simplifies down to 2. So we have 2 times 49 times 1/2. And then you can just plug that into a calculator, or you can think about it whatever you get, you should get the answer of 49 centimeters squared. All right. Now, if that didn't make sense, remember that in Edpuzzle, you can always go back and re-watch things to help you, because these are going to be the types of problems that we're going to be doing for the review as well. So then my last question that I have is, and you can use decimals, you can use the decimal form of the numbers now. I want to find the perimeter of the whole figure. So we already know most of the sides. We're just missing one other side. We're missing the side right here, which is a hypotenuse. What is the measurement of that side specifically? You can write it in either decimal or radical form. All right, so let's see how we would find that. 7 radical 2 squared, a squared plus, I'm using the Pythagorean theorem, plus 7 radical 2 squared equals c squared. Now, you guys have probably not done any of this squaring of radicals like this. When this happens, you are squaring both the number in the front and the number in the radical. So we get 7 squared times a radical 2 squared plus 7 squared times a radical 2 squared. 7 squared becomes 49. Radical 2 squared is just 2. Plus 7 squared is once again 49. And radical 2 squared is just 2. Making each of these 98. And that's what we're going to have to add together. 98 plus 98, you get 196. And then what we have to do is we have to take the square root of both sides. Well, when you take the square root of 196, you actually get a whole number, and it's 14. So now we want to add and want to find the perimeter of the whole figure. Now either in I want you to actually write this in specifically decimal form. What is the perimeter of this whole figure? So in order to find the perimeter in decimal form, the first thing we have to do is figure out how to convert that into its decimal form. Now, you can plug it into Google, is fine. I'm going to first find the square root of 2, which is 1.41421. It's a little long number. I'm just plugging that into a calculator and multiply it by 7. Which is approximately equal to 9.899. And then I'm just going to add all those numbers up. This plus 14 plus 7 plus 7. So when I add those all together, what do you get? The perimeter of this is going to be 37.899, and so on. All right, last one before we are done for the day. Here I have a problem that I would like you to solve for the purple area first. Find the area of the purple figure first. All right, so now let's review. This piece right here at the base of this triangle is going to be 5. If you didn't get that, then the rest of this problem would have been pretty tricky. And then once you have 5, you can use 5 to find this missing piece by using 5 and 13. 5 is a leg, and 13 is a hypotenuse. When you do this, you get 25 plus b squared equals 169. Then we subtract 25 from both sides. We get b squared equals 144. Take the square root of both sides. Get b squared equals 12. And now we have a base and a height of the figure, 5 and 12. And we can do, and so if you didn't get that, now try to get the answer now. And even if you did, just rewrite the answer if you got it correct the first time. We would do base times height divided by 2, so 12 times 5 divided by 2, giving it a total of 30 meters squared. Now what I would like you to do is, I want you to find the area of the whole figure. Now that's going to require a couple different calculations. We know the area of this one is already 30 meters squared. You'll have to find the answer for each of the other ones now. All right, let's start with the small one. I'm going to color code it to make it a little bit easier for you guys to see. So I'm going to name this one the red one, and that's going to be using base and height of 3 and 4. So 3 times 4 divided by 2, 12 divided by 2. So that equals 6 meters squared. I know that the purple one I already did already. I know the purple one is 30 meters squared. That was already done in the last problem. Now I'm going to paint this. The next one is going to be our blue triangle. That's going to be used with a base of 9 and a height of 12. So 9 times 12 is 108, I believe. I always get that one wrong. Good. Is 108 divided by 2, which is going to be 54 meters squared. And then that last one we have here, which I'll make green. Oh no, the issue here is we only have one leg, so we're still missing that other leg. So we have to use the information from the blue triangle to find that other leg. So in the blue triangle, and I'll switch back to black to make this a little easier to see. We know that the two legs are 9 and 12, so I can use 9 squared plus 12 squared equals c squared. 9 squared is 81, plus 12 squared is 144. 81 plus 144 is 225. And then when you find the square root of both sides, you get 15 equals c. So that missing piece we had here was 15 meters. Labels are important. So now I'll get back to that bright green color. To find the area of that figure, I'm going to do 8 times 15 divided by 2. 8 times 15 is 120. Divided by 2 is going to give me 60 meters squared. And now as my last step, all I have to do is just add up each of those 4 pieces. So 6 plus 30 plus 54 plus 60. And I get the total of what? You get the total of 150 meters squared. All right, guys, so there's a couple other problems on Classroom for you to give a try. See how it goes, try it out, and then next class, like I said, we'll do a review and a reflection. Have a great day, guys.